Hey champ, welcome to this quest. I am very sure you're familiar with the concept of work and you have several examples around you. A computer programmer writing codes, a tailor making dresses, a boy doing his homework, and a firefighter putting out fire will all say they are working. However, physics has a different idea of work. Guess what? If you keep a bucket of water on your head for an extended period of time, so long as you did not move, physics will say you've done no work on the bucket. But why is this so? Well, let's get to work learning about work. So, what is work in physics? Work is done when a force moves an object through a distance along the direction of that force. This means in physics, if you are sitting at your desk working, you've not done any work, but if you push the desk across the floor, then you're working. Work is a derived quantity and is given mathematically as work W equals force F multiplied by the distance moved in the direction of the force D. The SI unit of work is joule. Work can also be measured in Newton meter (Nm), and the SI base is given as kilogram times meter squared divided by second squared. Let's take a more interesting approach to work. By attaching a rope to my toy car and exerting force to move it a certain distance, I have performed work based on the definition of work. This is because the toy car qualifies as an object and I have applied force to displace it over a distance in the direction of the force. Note that there is an angle of elevation between the rope and the direction of the car. Let that angle be theta. So in this case, we would say the work done is given as W equals F times D times cosine theta. Don't be confused, I'll explain. If we isolate the triangle, we would have this. We will then use trigonometry to find the adjacent big D. Big D is the distance covered in the direction of the applied force. And since we know the angle as well as the length of the rope, small d, and we need to find the distance big D, we can use cosine theta equals to adjacent over hypotenuse. Hence, big D equals small d cosine theta. This is why I said work done will be written as W equals F times D times cosine theta. Now, let me ask you a question. What would be the work done if I keep a bag of rice on my head for 1 hour? Of course, the work done is 0 since the bag of rice was not moved through any distance. This is because the distance is 0 and the work done will be force times 0, which is obviously 0. Let's bring back my toy car. But this time, the rope is pulled vertically. That is, theta is 90 degrees to the horizontal. In this case, the horizontal distance D covered will be equal to small d cosine 90. Since cosine 90 is 0, then the distance covered will also be 0 and the work done in the horizontal direction will be 0. So, you will notice that instead of the car moving forward along the floor, the applied force will make the car move upward. This concludes today's lesson, but there is still much more to explore about work. So be sure not to miss the next lesson. Bye.